asking her to learn a new technology, but I don't tell her I'm going to do this to see her technology learning habits, to learn how to use a software program called Scratch, developed at the Massachusetts Institute of Technology, or MIT, to learn basic coding, computer science concepts and activities, and computational thinking, to move the cat figure, the sprite, from one side of the screen to the other side of the screen. As I tell her, she has 10 minutes to explore and 10 minutes to figure out the task. I also say that I'm interested in her thought process, so I'd like her to think aloud as she works. She nods, saying nothing. Then she takes hold of the mouse I've connected to the laptop, and I watch as the cursor moves across the screen. What is she thinking? What does she see? She notices a block, a visual chunk of code, with text on it that says, move 10 steps, and she clicks and drags it to the center of the screen. How did she know to do that? Why did she do that? She says she's unsure, but the words made her think that the blocks could move the cat. But why move the block to the middle of the screen? Jasmine says. I'm not sure. I smile. You're not sure? Okay. I note her willingness to try and fail, and how she's trying to decipher the design logic behind the blocks. She moves the cursor arrow across other blocks, reading what they say. She clicks and drags the one that says set X to 0 and places it above the first move 10 steps block, linking the two. She picks up another block that says set Y to 0 and connects it to her growing stack of blocks. Jasmine asks, can you change the numbers? I smile again. Can you? Jasmine smiles back at me, interpreting the learning process as a game, a way to manage frustration and boredom. She turns back to the computer. I think you can. She changes the number of steps and the value for X and Y, clicking on the set of blocks, making them flash, and the cat moves slightly. What is she thinking now? It looks like when you click on the blocks, the cat moves. She could keep clicking and moving the cat to reach the other side of the box and complete the task, but she doesn't stop there. Instead, she moves her cursor across the screen around the white box where the cat is located. What is she looking at now? She points out there are numbers, coordinates, she thinks, in the bottom right of the white box. They change as she moves her arrow. Connecting the software to the geometry she learned in school, so the use of models, she says it must be a coordinate plane. She matches the X and Y coordinates to the two blocks, the one that says set X to 0 and the other that says Y to 0, to the X and Y coordinates she sees when placing the cursor to the left side of the white box. She clicks on the blocks. The cat appears to the left of the box. Now it just needs to go to the right. It's 4 minutes and 50 seconds into the task. She drags another block to the center of the screen that moves the cat towards a mouse pointer. She plays it but quickly realizes it moves the cat in the wrong direction, to the left, where her cursor is located. She separates that block away from the others. She also separates the steps blocks she used earlier, focusing on the coordinate blocks, now that she's read the design in a way that she understands as a coordinate plane. She picks up another block that says go to X:0, Y:0. She changes the numbers to match the starting blocks, -237, -13, so that it's precisely at the same level, 237, -13. She clicks on the blocks and the cat moves from the left side to the right side of the box. While she found blocks earlier that moved the cat, she was looking for efficiencies, the fastest way to move it across the screen. It's 6 minutes and 40 seconds into the task, and she's succeeded.